we learned about the linear form of the differential equation. Now we will go to the differential equations which are not in the linear form. We have to convert those in the linear form. That is also called as the Bernoulli equation. So consider the general form of the non-linear differential equation as dy by dx plus py is equal to q y to the power n. Before there is only the q. Now we have an extra bit y to the power n. Now also here the p and q are the function of x, not y. So now we have to reduce those differential equations into the linear form. So how can you do that? So we have to reduce the equation into the linear form by substituting 1 by y to the power n minus 1 is equal to z. This is the substitution. So now what will you have to do? That take an example. Dy by dx plus xy is equal to x cube y cube. Okay, so now divide this y cube both sides. So what will happen? 1 by y cube dy by dx plus xy by y cube is equal to x cube, right? 1 by y cube dy by dx plus x by y square is equal to x cube. Now we have the substitution, that is 1 by y to the power n minus 1 equal to z. So let's take z is equal to 1 by y to the power 3 minus 2, 3 minus 1, that is 1 by y square. So here z equal to 1 by y square. Now dz will be minus 2 by y cube dy. That implies dz by dx is equal to minus 2 by y cube dy by dx. Look at this. 1 by y dy by dx is equal to, and here we have minus 2 by y cube dy by dx. Don't these look familiar? We can do something like this. So we have to bring 1 by y cube dy by dx here. So we can do that by dividing that minus 2 here, and voila, our term is here. 1 by y cube dy by dx, 1 by y cube dy by dx. So now we can substitute this in the place of this. So this becomes 1 by 2 dz by dx plus x by y square is equal to x cube. We also know that 1 by y square is equal to z here. So minus 1 by 2 dz by dx plus 1 by y square becomes z. So xz is equal to x cube. Now let's get rid of the 2 and minus 1. So how can we do that? So dz by dx plus multiplied by minus 1 divided by minus 1 by 2 is equal to x cube by minus 1 by 2. Now dz by dx minus 2xz minus 2x cube, right? Now we can see that it has reduced to the linear form. The linear form was dy by dx plus p dy is equal to q. Here we have dz by dx minus 2xz is equal to 2x cube, where p is this term and q is this term. Now we can solve those by the linear method we know, by taking the integrating factor. Integrating factor will be e to the power minus 2x dx and its integration. So it becomes minus 2x dx. That will be e to the power minus 2 x square by 2. Right, that is equal with e to the power minus x square. Now we can solve this. So we have the general formula, that is y into integrating factor is equal to q into integrating factor, its integration with respect to dx plus c. That is, here we have z instead of y, so z into integrating factor is e to the power minus x square, that is equal with q here is minus 2x cube, minus 2x cube into e to the power minus x square dx plus c. Consider here minus x square as m, so minus 2x dx is equal to dm. So we can say that this becomes z into e to the power minus x square is equal to, here we can split that minus 2x dx. I am splitting this into x square into e to the power minus x square plus c. Right, so this becomes dm into x square is m, so this is minus m into e to the power minus m, e to the plus m plus c, that is equal with minus m into e to the power m plus c. Now z into e to the power minus x square is equal to integration of m into e to the power m plus c. So we can solve this integration by parts. So let's take I1 is equal to m into e to the power m and its integration with dm. Oh, I forgot this dm. So this will become m into e to the power minus e to the power m dm minus dm by m integration of e to the power m dm and dm. So I have used the formula I let, where a is algebraic, t is trigonometric, e is exponential, l is logarithmic, and I is inverse trigonometric function. So here we have algebraic and exponential, so algebraic comes first. So the formula is the first function f1x integration of f2x dx minus dy dx of f1x integration of f2x dx with the integration dx. So this is the general formula I have used. So this equation our becomes m, the integration of e to the power m is e to the power m minus this becomes 1, so e to the power m dm integration and integration. So m e to the power m minus e to the power m, so this becomes m minus 1 e to the power m. So we can substitute this value into this value. So z e to the power minus x square is equal to minus of m minus 1 e to the power m plus c, right? So z e to the power minus x square is equal to e to the power 1 minus m e to the power m plus c. Now we have z equal to 1 by y square, and m here is minus x square. So after putting these values, we get e to the power minus x square by y square is equal to 1 minus of minus x square is 1 plus x square into e to the power minus x square plus c. We can separate the x and y terms. 1 by y square is equal to 1 plus x square e to the power minus x square divided by e to the power minus x square plus c, that is equal with 1 by y square is equal to 1 plus x square plus c. So this is the final answer. I am attaching some more homework for this, so you can try this. So these are the questions you should try and solve yourself, and the topic is completed. Thank you.